Isomerism in coordination compounds. So, in order to understand the different isomerism in coordination compound, we should understand the term isomerism. Isomerism is the phenomenon in which compounds will have same molecular formula but different structures. So, the compounds which will have the same molecular formula but differ in their structural arrangement are known as isomers. And this is mainly because of different structural or spatial arrangements. Hence, we have different types of isomerism. The types of isomerism shown by coordination compounds are structural isomerism and stereoisomerism. So, the structural isomerism is the compounds will have same molecular formula but different structures. And in stereoisomerism, in this, compounds will have same molecular formula but it will differ in spatial arrangements of the ligands. So, if we talk about structural isomerism in detail, we should understand the first type of structural isomerism is ionization isomerism, and this will occur due to the exchange of ions in coordination sphere of metal ion and the ions outside the coordination sphere. So basically they will differ in the productions of ions in aqueous solution. For example, if we take COBr NH3 5SO4 and CONH3 5SO4Br, here are considered to be ionization isomers. So when it is dissolved in water, it will dissociate as COBr NH3 5 2 plus plus SO4 2 minus, and here it will be Br minus. So they are differing in production of ions in aqueous solution. So they are considered to be ionization isomerism. The second one is hydrate or solvate isomerism. In this, they will differ in number of molecules of water of crystallization, and this will occur when water is a part of coordination entity or it's outside it. So, it is isomerism in which the solvent is involved as the ligands, and these two are considered to be the hydrate isomers. The third type of structural isomerism is coordination isomerism, and this will occur in those complexes which are made of cationic and anionic coordination entities due to the interchange of ligands which happens between the cation and anion entities. The fourth type of structural isomerism is linkage isomerism, and this occur in complex when an ambidendent ligand is being present in the coordination sphere. So these are all the four types of structural isomerism. And the next one when we talk, it is stereoisomerism. Stereoisomerism, as we have said, that it is of two types, geometrical isomerism and optical isomerism. Geometrical isomerism is because of the difference in the geometrical arrangements of ligands around the central metal atom, and two coordination compounds will be considered to be geometrical isomers when they are differing in the arrangement of their ligands in space. And geometrical isomerism is further classified as cis and trans. In cis, when there are similar ligands will be on the adjacent position. Trans, when the similar ligands are placed on the opposite position. then we call it as transgeometrical isomerism. The second type of stereoisomerism is optical isomerism, and this is basically shown by the chiral molecule, that is, the molecule which will not have plane of symmetry. Or in simple term, if we say optical isomers are those isomers which are non-superimposable mirror image, which will have non-superimposable mirror image. So those type of isomers we are calling it as optical isomerism. So isomerism is a very important concept from the chapter of coordination compounds because it is very frequently being asked in the examination.